We saw earlier how positively charged metal ions are formed when metal atoms dissolve in water. The electrons that they leave behind produce a negative charge, and if oxygen is absent, this voltage rises until further ionization stops. By measuring these voltages, it's possible to rank metals. You can also forecast what will happen when two different ones are put into an electrolyte and connected together to form a galvanic cell. The metal with the highest wet corrosion voltage acts as the anode. It starts to corrode and electrons flow from it to the other metal. This then becomes the cathode, where the oxygen reaction takes place and no corrosion occurs. When aluminium and stainless steel are connected together, the aluminium becomes the anode. Aluminium rivets must therefore not be used on stainless steel, or they will preferentially corrode, as you can see. Obviously, galvanic corrosion can be prevented by keeping the metals dry or electrically insulating them from each other. However, stainless steel rivets could be used on aluminium if its relative surface area is so large that the current density will give a tolerable thickness loss of aluminium. On the other hand, galvanic corrosion can be used to protect a metal. For example, galvanizing protects carbon steel because the zinc coating becomes the anode and corrodes preferentially. Unfortunately, protection stops when all the zinc is used up. Salt seawater is very corrosive, but the carbon steel legs on this offshore platform are protected by fastening blocks of magnesium alloys to them. This is the inside of a seawater cooled steam condenser. The piece of carbon steel acts as a sacrificial anode. It protects the stainless steel tube sheet from galvanic corrosion by the more noble titanium tubes. There are many other times when using galvanic protection is impractical, and this is where the special oxide film formed on stainless steel becomes so useful. Many types of stainless steel have been developed to resist different corrosion environments and different working conditions. Stainless steel ensures that works are safe, that things last longer, that our food is hygienic and free from contamination. It is even used for equipment to clean up the exhaust gases from cars and power stations. But that's not all. When old stainless steel is scrapped, it can be remelted to make new high-quality stainless steel. And this can be done as often as you like, allowing the same material to be used by all future generations, perhaps for applications that you may only dream of.